Why is it so difficult to return to the moon if we've done it before? The last time a human was on the moon was in 1972. Since then, technology has taken giant steps, and more countries have developed their space program. But despite this, human beings have not returned to visit the moon. What are the reasons? Let's find out. The main motivation. To find the reasons that led to the trip to the moon, we have to go back to the end of the decade of the 60s. After World War II, during the Cold War, the United States and the Soviet Union engaged in the space race, a stubborn struggle between the two powers whose ultimate goal was to place a citizen of the nation on the surface of the moon. From this struggle, in which both nations intended to demonstrate their military and technological superiority over the adversary, the United States would emerge as the winner. The trip to the moon, more than an end in itself, was a way to show the world who would set the pace of the international political agenda for the remainder of the century. Reaching the moon had more of a political purpose than a scientific one. In a different historical context, out of simple scientific concern, would we have reached the moon in 1969? Everything seems to indicate that it does not. As we have said, the motivation for the Americans to send a human crewed mission to our satellite was the tension generated by the political situation. Without this rivalry with the USSR, it would have been hard to imagine that the American government would mobilize the nearly 400,000 people who participated in the Apollo program and dedicated to it during the 14 years that it lasted, the equivalent today of about $120 billion. Today, it is unimaginable that the U.S. government would again fund a trip of this nature at such high cost to the nation. The high cost of stepping on the moon again. Reaching the moon was not an easy feat to achieve because, in addition to the technological challenges we will discuss later, there were so many economic challenges. A law signed in March of 2017 by President Donald Trump gave NASA an annual budget of around $19.5 billion and stands at nearly $20 billion today. But although this sounds like an astronomical figure, in reality it is not, if you consider that the total is divided between all the divisions of the agency and all the ambitious projects like the James Webb Space Telescope, the giant rocket project called the Space Launch System, and remote missions to the Sun, Jupiter, Mars, the asteroid belt, the Kuiper belt, and the edge of the solar system. In addition, NASA's budget is somewhat small relative to its past. Since 1960, the economic allocation dedicated to the American space program skyrocketed, reaching the record figure of 5.3% of the national budget in 1965. But 5 years later, in the early 70s, and resolved the space race in favor of the Americans, NASA suffered a significant budget cut for various reasons, including the loss of political interest in the moon and the accident the Apollo 13 mission suffered. These events would lead to the cancellation of the Apollo 18, 19, and 20 missions, making Apollo 17 the last human-crewed mission to the moon. As a result, for the past 40 years, NASA's budget has remained below 1%, and for the last 15 years it has been heading towards 0.4% of the federal budget. In other words, if today we have not returned to the moon, it is, on the one hand, a lack of interest on the part of governments, and secondly, a lack of economic resources. What happened to technology? Today, NASA has the new rocket SLS Space Launch System, which will be the successor of the Atlas V that was responsible for taking astronauts to the moon. This rocket made its debut at the launch of the Artemis 1 mission, which was a success, managing to take the Orion capsule to the orbit of the moon, which will be the new spacecraft that will transport humans to the lunar surface. Something that caught the attention of many is that before the launch of the Artemis 1 mission, it was canceled twice due to failures in the rocket's fuel chambers of the rocket, and therefore it was necessary to perform more tests before the ship could be launched. But why was it so difficult to launch the SLS? Isn't NASA supposed to have years of experience already? The reality is that the launches of the Apollo missions were not easy either. As you will remember, the mission that managed to land successfully was the 11th. That is to say, before Apollo 11, 10 missions did not get it for various reasons. Most of them had several cancellations either due to weather problems or technical problems. Some Apollo missions didn't even get off the ground, but it's hardly talked about. It's also worth remembering that during the space shuttles, NASA had many problems getting them to take off, even though they already had the experience of the Apollo spacecraft. The most common problems during shuttle launches were almost always in fueling systems, since this was not the same as that of Saturn V rockets and Apollo spacecraft. The shuttles were extremely complex craft that mixed a rocket's power with an airplane's aerodynamics and had engines that used solid and liquid fuel. This complexity was what caused technical failures in all launch attempts. In fact, according to the Registry of Launch Cancellations, shuttle launches are the ones that suffered the most cancellations. Some were canceled up to 5 times before taking off successfully. The problem of fuel supply. Before successfully taking off, the Artemis 1 mission was canceled twice due to technical failures in the fuel system. These failures are the same ones that caused the cancellation of the Apollo missions and the same ones suffered by the shuttles. Fuel leaks are the most common failure in rockets and one of the main reasons for takeoff cancellation for more than 50 years. But why does this problem still exist today? The fault lies with the fuel used by the rockets, hydrogen. This is the simplest and lightest element of all on Earth. It exists in abundance, but it is mixed with other elements, and molecular separation processes such as electrolysis must be used to obtain pure hydrogen. Hydrogen is a highly light element, so much so that putting together a single gram of material requires billions of hydrogen atoms. Hydrogen is so light that it can sneak through any opening, however tiny it may be. In a typical environment in average temperatures, this is not usually a problem, but leaks are much easier to occur in a cold environment and high pressures. It is precisely these environments in which space rockets operate. For a rocket's fuel tanks to maintain full of fuel, they must be permanently connected to terrestrial cooling systems by cables and hoses until the moment of launch. At the time of takeoff, some connections separate from the bridge. It is right here where leaks usually occur, since these connections cannot be screwed tightly, and it is tough to avoid leaks when they are at high pressures and shallow temperatures. In short, it's hard for the rockets to take off because hydrogen is used as fuel. But if this is the problem, why not use another fuel? Reusing rockets. The reason why NASA continues to use hydrogen fuel is its high efficiency, since it is the element that provides greater thrust and less weight. Still, another important reason is the law. We're not talking about physical laws, but political ones. In 2010, the U.S. Congress ordered that NASA would have to continue using the rockets that were used in the shuttles as part of the SLS rocket program. In fact, you may not know it, but the SLS engines are the same as those used by the space shuttles at the time. As the budget was cut, Congress suggested that to optimize resources, NASA would have to use the contracts, investments, budget, workforce, industrial base, and the existing infrastructure in the U.S. that were used for the space shuttle in the new SLS program. Likewise, would also be reused the Orion 1 and the existing propulsion systems such as the liquid fuel engines that caused so many leaks. The external storage tank and the solid fuel engines would also be reused. All this was reused and conditioned to the new Artemis 1 project. In other words, the Artemis project, which seeks to take new astronauts to the moon, uses the same technology, rockets, engines, and launch base that the space shuttles used more than a decade ago. That's why getting back to the moon is so tricky. Beyond touchscreens, the technology of the Artemis 1 program is not so different from what we had 50 years ago. Moreover, perhaps the most potent reason we haven't returned to the moon is the simplest of all. There hasn't been a need to go back. The missions of the Apollo program were so prolific that apart from the countless experiments carried out on the moon, so many samples of lunar material were collected that even today, many of them remain unstudied by scientists. To all this, we must add that in the coming years, NASA's interest will focus on objectives such as Skylab, the laboratory in Earth orbit, or sending probes and satellites to many other corners of the solar system. And perhaps the question is, why should we return to the moon when there is so much still to be explored on the rest of the planets? In light of recent scientific advances, there's nothing to criticize NASA for. Today we explore Mars with robots, discover new solar systems almost daily, and detect phenomena such as gravitational waves that until very recently were only part of the theory. As we have seen, there are several reasons why we have not been to the moon since 1972, and yet none has to do, for example, with the strange conspiracy theories circulating for several years on social networks. Just because we haven't come back doesn't mean we won't. The horizon of the next human-crewed mission to our satellite will be marked by NASA's Artemis project that aims to put a man back on the moon. And it may also be that, on this occasion, imitating Neil Armstrong in 1969, is a woman who takes a new step on the surface of our natural satellite.